Hi friends, welcome back. Now let us see the next UML diagram, that is the sequence diagram. The previous sessions we have seen about the use case diagram and the class diagram. Now it is time to see what a sequence diagram is. A sequence diagram is a type of UML diagram that shows how objects interact with each other over time. So they interact with each other, one issue, and over time. So here time is also considered to complete a particular use case or a process. So we have a use case for completing that use case. Different interactions take place among the various components of the system. So what interaction take place and in what time sequence they occur and all that will be shown by the sequence diagram. So the key features for the sequence diagram, that's a lifeline, that is a vertical dashed line representing the objects or the actors that participate in the interaction. Then we have messages, that's a horizontal arrows that show communication, that is the method calls or signals or data exchange between the lifelines. So the lifelines are the vertical dashed lines which represent the objects or actors. So between the objects, if there is any communication going on, that some messages are passed from one object to other object, then we show it through horizontal arrows, and that's what we call messages. And then we have activation bars, thin rectangles of the on this lifeline showing when the object is active. So that means when the object begins to work for something and how long it works, so that is shown by a rectangle. Then we have order of events, that is the messages are arranged from top to bottom showing the sequence of interactions in time order. So the one which occurs first is shown on the top, one occurs at the last shown at the bottom. So this vertical axis from top to the bottom is a timeline. And we have control structures like loops, alternatives, and conditions can be represented on this. So why do I think that sequence diagrams are important? Because they show the step-by-step flow of a use case. So for completing one use case, what all the actions taken, so step by step these activities are shown. Then the clarity in responsibilities of the objects are shown here, so it clarifies the responsibilities of the objects and then make it easier to implement the code since it resembles the function call. So it shows that each message is a function call, so the call initiated by someone and goes to someone else. So this it becomes easier to implement the code and helpful for debugging and testing the workflows. So just looking at the whole situation on one sheet, it very easily can make out that in what order who is communicating with whom and all that, and if there is any mistake then we can easily correct it. Instead of looking at the implemented code, finding the mistakes there, it is better to debug and test the workflows at this sequence diagram only. Now the question is how to create the user diagram. As we just discussed in the beginning, that the base of every design activity is the use case diagram, therefore sequence diagram also should be written from the use case diagram. So how to create a sequence diagram from a use case diagram? So first thing is understand the use case. So from the use case diagram, say example is a fraud detection machine learning system. So let us pick one use case, that maybe detect fraud is a use case. Here the actors are the customers who initiates a transaction, then the fraud detection system which checks the fraud, and the fraud analyst reviews the flagged frauds. So there is uh, a transaction is going on, the transaction is initiated by the customer, and then the initiated transaction sends a message to the fraud detection system that a transaction is initiated. Before we take up the transaction, just make sure that there is nothing fraud in that, so please check whether this transaction is fraud or not. And if it says there is no fraud, then the transaction is continued. If there is fraud, then it will be stopped and the transaction cannot continue. Appropriate messages are created, appropriate logs are created, and so on. And to make sure that our system is working correctly, we may have some fraud analyst who reviews our fraud report and confirms that our system is working correctly. If there is any wrong, uh, it may happen that our fraud detection system may call a fraud as a not fraud, or not fraud transaction as a fraud. So two types of errors are possible. So any error is there, then fraud analyst will try to identify, and that will help in remodeling our system so that these flaws can be avoided. Then the use case is broken into steps, the scenario. So for example, the flow for detect fraud: the customer performs a transaction, then the system validates the transaction, then the system runs the machine learning model to detect the fraud. If flagged, the system will notify the fraud analyst that there is some fraud detected. You please better check it and confirm whether the system detected fraud is real one or not. Then the fraud analyst reviews and confirms or rejects the fraud, and the system sends the result to the customer. Then identify the objects and the lifelines. So each become a vertical lifeline in the sequence diagram. A customer is one lifeline, then transaction system is another one, fraud model is one more, and fraud analyst is the next one. Then define the messages, then add the arrows for the interactions, make transactions. So here customer to transaction system, one message is forwarded, then the next message forwarded is validate transaction. So this is done by the transaction system itself. That means it's a self loop. So it checks itself whether the transaction is valid or not, and then it wants to verify whether the transaction is fraud or not. So for that, the message is forwarded to the fraud model, and it verifies whether the transaction is fraud or not, and then notify fraud analyst. So the result of the transaction or the result of the fraud model is forwarded to the fraud analyst. If there is any suspected fraud, then it is forwarded to the fraud analyst, and want real-time verification, because at the end human can be the best verifier. So he'll analyze whether the fraud suspected is really a fraud, or is a error by the system, and then review the fraud case. This here the fraud analyst will send the review report to the system, and then the system will send result to the customer. So here we have customer to transaction system, make transaction system to transaction system, validate transaction system to fraud model. So run fraud check given the data, then fraud model to transaction system, that whether it is fraud or not. Alternatively, if fraud is detected, then the transaction system will send to the fraud analyst, notify that such a transaction is identified as a fraud by the system. You please verify, and then the fraud analyst will verify, and that review report is forwarded back to the transaction system. And at the end, the transaction system will send back to the customer the result. So this is how it looks like. The customer initiates a transaction, so make transaction goes to the message goes to the transaction system. It asks the fraud model to verify whether this is a fraudy transaction or not, and then it will notify back what happened. So if there is any fraud, then it will be forwarded to the fault analyst. If there is no fraud, then it will just send back the report. So notify the fraud analyst, then the review fraud case is sent back to the transaction system by the fraud model, and this whatever has come back, it may be a fraudy or it may be not fraud, this result is finally sent back to the customer by the transaction system. So we can see that these are the various actions going on. Messages are being transferred from one object to other object, and at the same time timeline is also shown here. So take another example for placing the order in the online system. So customer to app UI, so it selects the items from the app, and then customer to app UI sends a message, say place order, and then app UI will forward the message to the order controller that place these orders, these items to be placed as order. Then order controller will send message to the order that create an order. Then order sends to order then to calculate the total, and then order controller will send information to the restaurant service. It notifies the order what order is confirmed by the customer, and the order controller will forward a message to the delivery service to assign an agent for the given order. And then we have a order controller sending back to the app UI to show confirmation. So it's a simple way we can look at it. There is a customer here, there is an order system here, there is a restaurant here, and a payment gateway here. So first action is initiate by the customer, place order, then forward the order details to the restaurant, and restaurant will confirm the availability of the order. So whatever order is placed, it should be available with the restaurant. If it is available, then it will confirm. If order is confirmed, then that message goes back to the customer, and once order is confirmed, the customer will start for payment, and this payment first goes to the order system. From order system it goes to the payment gateway to process the payment and then confirm the payment. So get the details like credit card or debit card details and password and all that. So once that whole process is done, then confirmation message comes back to the order system. Then order system will notify to the restaurant that the payment is done with the order system, so you can start your preparation of the order. Then it starts preparing, and then finally from the restaurant to the customer the order will be delivered. So that's a simple way of talking of that. So if you look at in more detailed way, we have one lifeline as a customer, then online food ordering system. This is the system which we are developing. So there is a database about the restaurant, there is restaurant, the gateway for payment, and finally there is a delivery person. So it begins with the select the restaurant, then fetches the menu returns back from the restaurant database, so that the menu is displayed to the customer will select the items, places the order, and this order is sent to the restaurant, and restaurant confirms the order. Once the restaurant confirms the order, our system will send a confirmation message to the customer. Then the customer will start initiating the payment system, then starts making payment, and then goes to the payment gateway, and this payment is checked up and verified. And once the payment is done, then the message comes back to the online food ordering system, and then it sends to the customer saying that your payment is confirmed. Then the delivery person will be initiated to collect the order, and then the delivery person will send the order to the customer. So the delivery person will pick this order from the restaurant and then drops to the customer's location. So that's how the overall things are. So it becomes very clear to understand how the system is behaving and all that. So that way we can make the system visible very clearly, unambiguously. This is for one use case, for one particular situation. So there may be many such things. So for each we will be writing a sequence diagram like this, and finally combining all of them together to make one sequence diagram for the whole system. Or we can keep them in a module wise, so that for each module, once it is built, it will be verified with this sequence diagram and checks whether it is working in line with this sequence diagram or not. If no, then we have to correct that and all that. So that's about the sequence diagram. Thank you.